In the name of God, hello dear students of grade 7. My name is Masoud. I'm a science teacher. I want to welcome you to Thinkable Physics, my YouTube channel. Uh, so far we talked about states of matter, and we said that matter in general in nature is of four states: solid, liquid, gas, and plasma. Solid state like uh, actually majority of irons, majority of metals like iron, like silver. These rings are silver, like wood, like rock. They are solid. And liquid like water, like juice, like milk. And this is about the liquid. An example of gas, for example, whenever you use a deodorant, this deodorant is in gas state, or whenever you blow up the balloon, you actually enter you fill the balloon with air, and you know that the air is a mixture of gases. An example of plasma, actually, we have a lot of examples of plasma, fourth state of matter, and we said that the plasma actually is produced in very high temperature, like for example stars are in plasma state. Even a sky of a universe, the sky is an example, another example of plasma. We can say a lightning, another example of plasma, and a flame of fire. So this is the summary of previous lecture. Right now we are going to classify the matter and focus on properties of each state. For example, whenever we want to talk about the solid state, we perceive the properties of solid. Whenever we move to the liquid state, we concentrate on the properties of liquid, and so on for the other actually states. Right? Let's start our subject with particles of matter. And in previous lecture, we said that structure of matter is actually atom and molecule. But I didn't tell you the size of either. I want you to guess the size of molecule and atom. Tell me which one is larger, which one is smaller. Keep in mind that atom is the building block of matter. Building block means the smallest part of the matter is atom, right? Which is invisible. You cannot observe it by your naked eyes. You have to put microscope above a piece of any substance to observe the atoms. One more expression which is very important, we name it as molecule. Molecule is a group of atoms, right? So atom is the smallest part of substance, but atom is the smallest part, but molecule is a group of atom, collection of atoms. So which one is larger? I'm sure you got the answer, because I say group of atoms actually makes one molecule. That's why atom must be smaller than the molecule, right? And keep in mind that molecule is invisible as well, right? This is about the actual previous lecture. I'm gonna actually draw for example, and I'm gonna draw a molecule and an atom. This is one atom, right? This is one atom. And what are these? If I gather, for example, if I gather a group of atoms, this collection is called molecule. molecule. So molecule is larger than atom in size, right? And both of atom and molecule are not visible to human eye. We cannot actually observe them. Let's start our subject, particles of matter. Matter is made up of tiny particles called atom and molecule, right? I think I explained this subject, atom and molecule, in its previous lecture. Just I want to read it. Actually, I want to read it quickly, and I underlined it for you in previous lecture. These particles are too small to see without a powerful microscope, means they are invisible. Atoms and molecules are always in motion. They are in motion, they interact with one another, they collide with one another, and they they bounce back at the surface of each other. One molecule or one atom pushes back the other, and so on. So there's an interaction between these actually particles. These particles interact with each other, and the way they interact with each other helps determine the state of matter. And this actually these interaction, for example, within a matter, determine the state of matter, determine the state of matter, which is solid, liquid, or gas. This is an introduction or summary about the previous lecture. Right now, we are going to start a new subject, which is properties of solid state. So right now we are in solid state. Let's read the properties, and I want you to be with me. Put your book in front of yourself. When I underline important information, I want you to underline it like me, actually, to better understanding. And after me, you have to actually memorize this information. Let's start the properties of solids. Solids have definite shape and volume. Two important actually information. What are these? Number one, definite shape, right? Definite volume. Number one, definite shape, definite volume. Number one, definite shape. Number two, definite volume. Two properties of solid particle, right? Definite shape means the shape of this solid, this piece of wood actually, is definite. It's a certain shape. You can name the shape of matter, which is, for example, you say we have a parallelogram, for example, parallelogram solid, right? It has a definite shape, definite volume, and the shape and volume don't change. Neither volume nor shape of solid changed, right? The particles of substance in a solid are very close to one another. The third information, they are very close to one another. They actually they sit beside each other very strongly, very closely actually. The attraction between them is strong. The fourth information, attraction. So each particle sit beside the other in a very small gap, and these particles attract one another by a strong force, right? The particles in a solid move. They are vibrating. So vibration is one more actually property of solid state, vibration. So vibration means the motion is not freely motion. It's a very actually small motion. Vibration means moving up and down. Moving up and down means actually vibration. So they are properties of solid. It says figure 2, there are two kinds of solids, crystalline and amorphous. So in general, about the properties, we have 5 properties. I underlined them. Right now, we are going to classify solid among themselves. How many types of solids are there? There are 2 types of solid, crystalline and amorphous. Let me highlight for you. So crystalline, amorphous. They are two types of solid, right? And by the way, the definition of state of matter is important. You have to memorize it. Even if I don't actually highlight it, these definitions are very important. I want you to memorize them. Very actually, you have to concentrate on the definitions. So right now we have types of what? We have two types of solids. But there's a mistake here. I want to correct the mistake. There's a mistake in types of solid. The title, let me correct the mistake, and I want you to guess the mistake here. There's a, let me actually erase it for you. The title is wrong actually. Amorphous, this information is not about the amorphous. This information on the left side is about crystalline solid. And the information on the right side is about what? Is about amorphous, not crystalline. So there's a mistake in what? In writing the titles. I want you to change the titles. Here, change the amorphous to the crystalline and change the crystalline to the amorphous. Right. I'm gonna erase it. So right now we have no amorphous and crystalline. I'm gonna change the title like this. This is the title of this one is crystalline, right? The title is crystalline. What do you say about another title? It's not actually. This is amorphous. Amorphous. Right? So let me read the definition of crystalline solid. Crystalline solid, they are metals. They have particles arranged in a uniform, orderly pattern. They actually sit beside each other. They pack actually very closely to one another, such as diamond, iron, and ice. So we have three examples. The examples actually are iron, number one, diamond, iron, and ice. So what's the crystalline solid? It means the solid in which the particles of solid. What do I mean by particle? Particle means atoms and molecules. They are arranged, they are organized, let's say. They are organized and they packed very uniformly beside one another. They sit beside each other and they form a regular pattern, which is called crystal lattice. Crystal lattice is the shape of the array of atoms in crystalline solid. So this is about the crystalline solid. Particles sit beside each other in a regular pattern, such as iron, diamond, ice, silver, and so far, and so on. Excuse me. About the amorphous, is made of particles. Is made of particles that are not arranged, right? That are not arranged. If you take a if you get back to the crystalline solid, we said that particles are arranged in a what? In a uniform pattern, uniform orderly pattern. But here we have an opposite case. Particles are not arranged in a uniform pattern, so we have an irregular array of atoms in amorphous solid in any particle pattern, like rubber and candle. Rubber, candle, glass, plastic, they are example of what? They are example of amorphous solid, right? Let me, and by the way, this self-check is homework for next lecture. I want you to solve this, I want to answer this question. Self-check, how solid state matter different from another matter?